pH indicators are substances that change color depending on the acidity or alkalinity of a solution. pH indicators are specific to a range of pH values one wishes to observe. For example, common indicators such as phenolphthalein and methyl red are used to indicate pH ranges of about 8 to 10 and 4.5 to 6 accordingly. On this range, phenolphthalein goes from colorless to pink, while methyl red goes from red to yellow. Nature contains several natural pH indicators. For example, some flower petals, especially roses and hydrangeas, certain fruits, like cherries or strawberries. In my case, I'm going to use red cabbage. Red cabbage contains a pigment molecule called flavin or tocyanid that gives its characteristic color. It also changes color depending on the acidity of the solution, as you will see in this video. The whole method is quite easy. I start by cutting the red cabbage into smaller pieces. As you can see, I struggle a little because I use not a big enough knife to cut it, but if you aren't the dumbass like me, you shouldn't really face any trouble doing it. I use a quarter of it because I really didn't need a lot, but you can use as much as you want. I then transfer it to a large beaker on top of an electric stove and then added enough water to cover everything up. When enough water was already added, I then turned the electric stove on and covered the beaker with a glass pot lid. I let it reflux for 20 minutes. As time passed, water got more and more purple until getting to this dark purple color. I then just turned the electric stove off. When it was cold enough, I filtered it to an aluminum flask. I didn't have a filtering flask, so I used the top part of a milk bottle to it. Sadly, it didn't fit well, so I added another top part of another bottle and then added the top part of the milk bottle on top. I then started filtering everything through a filter paper.
Bruh.
I then started filtering everything through a filter paper. At a certain point, it started getting a little slow, so I got desperate and tried using a screwdriver to help making it faster, but ended up making a hole in the filter paper instead. So I changed it, but this time waited till everything went through. I then washed the beaker 2 times with some water. I got left with around 250 ml of the solution. I then transferred it to a vial and a glass bottle with a dropper. All the solution I got left I just threw it away. I finally made some tests with it. I made 7 solutions with different substances and added a few drops of the pH indicator to see the color change depending on the pH of the solution. As you can see here, the only solution that changed to a color different than what it was supposed to was the soap one. I thought it would change to a blue color, but changed to a pink one instead. This means this solution was more acidic than what I thought. Either way, the pH indicator seems to work perfectly. Another important aspect about pH indicators is that when the pH changes, the color changes too, so it is reversible. For example, I used this solution containing sodium bicarbonate and added some muriatic acid. You can see it changed from a blue color to a red one. I did the same experiment, but this time the other way around. Stupidly, I didn't calculate the adding pace of the sodium bicarbonate correctly and everything overflowed. However, I got left this cool dark blue solution as a result. Anyways, I hope you liked this video and see you in the next one. Bye!